Ibu dan Bapak, saya hormati, selamat datang di workshop dari perusahaan Laserworld dengan asiis tentang topik laser systems dan integrasi laser systems dalam lighting system dan inspirasi untuk ide baru untuk konsep lighting. Dan aku selaku sales manager untuk Laserworld dan negara Indonesia dan negara lain di Asia. Sekarang ini Pak Andi, CEO dari asiis dan CMO dari Laserworld, Norbert Stangl. Okay, enjoy guys.
Okay, thank you Milan for your introductions. Terima kasih Milan buat introductionnya. Dan sekarang kita akan we gonna go direct for the presentations, ya. Dan sekarang kita akan saya akan membantu Mr. Norbert ya untuk translate dalam bahasa Indonesia. Dan mari kita sambut Mr. Norbert dengan tepuk tangan.
So, welcome everybody to the workshop. We're talking about lasers today. Let me introduce myself first. My name is Norbert Stangl. I'm from Germany. Basically, you see from the name, I'm not a local, but I am CMO of the Laserworld Group. We're a worldwide group of companies dealing with show laser lighting. I'm also head of the
Translate you first.
Yes. Okay.
Oke, selamat datang di workshop untuk Laserworld ya. Dan dia Mr. Norbert, dia dari Jerman yang akan presentasikan tentang laser.
Yeah, just some words about me, so you better know who I am and what I do. I got a graduate in business administration, and I've got 15 years experience in the laser industry and 20 years experience in the AV industry. So not only lasers, I also know quite some things about lighting and sound, so I know what the industry is about.
Oke, sedikit gambaran tentang dia ya. Dia sudah ada 15 tahun bekerja di dalam industri laser ya, tetapi dia juga memiliki 20 tahun experience di AV industry. Dia dari Jerman. Dan dia di AV industry dia tahu tentang video, tentang sound yang membuat dia sendiri juga lebih pede tentang. Oke.
Yeah, I'm responsible in our company for the international marketing, the software product development, the Laserworld Group IT, laser safety and LSO training, which is an important part of laser technology, and also the education and training. I work in Switzerland and I live in Germany, so I travel every day across the border. So yeah, it's a beautiful area in Germany, south of Germany.
Oke, Mr. Norbert ini bertanggung jawab untuk international marketing di Laserworld. Dia juga bertanggung jawab sebagai software product development, pengembangan produk dari software untuk Laserworld. Laserworld Group IT juga sebagai expert in laser safety dan LSO training. Dan dia juga bertanggung jawab untuk education dan training. Dia bekerja di Switzerland di kantor pusatnya mereka. Tetapi tinggalnya di Jerman dan dia sudah menikah ya, jadi jangan cari India lagi. Okay, please.
Okay, so I wrote a short agenda so everybody knows what we're talking about, so you find yourself somewhere and see what we deal with. So first of all, introduction, then the company profile. I just want to give a short introduction of the Laserworld company. Then we talk about understanding laser systems, different types of laser shows. Think lasers from a designer's perspective, so especially as I know that there's quite some lighting designers here, I just want to give you an insight on what you can actually do with lasers, you know, some visual impression, but also some technical backgrounds. And I will explain you how lasers work, so kind of a technical background, how the lasers are actually constructed and how they work and how you can control them. Then on how you find the right laser for your application, because there's many different applications where you can actually use lasers. Then we have a close-up on the laser system, we have a look inside, and we will talk about lasershow control software, which is a special thing. And finally, we will talk about laser safety.
Oke. Tadi sudah ada introduction tentang Laserworld, dan setelah ini dia akan sedikit menggambarkan tentang company profile dari Laserworld. Lalu kita akan lebih memahami tentang laser system, macam-macam laser system, ya. Lalu kita juga bisa berpikir tentang laser dari perspektif lighting designer, bagaimana laser bekerja, ya. Dan kita nantinya kita akan mampu mengetahui laser apa yang kita butuhkan untuk setiap aplikasi. Laser system secara close up nanti kita bisa sama-sama melihat, ya, apa yang ada di sini karena dia sudah buka modul-modul ini. Lasershow control software, dan terakhir adalah safety dari penggunaan laser itu tadi. Jadi ini workshop yang sangat menarik yang akan menjadi bekal kita untuk dapat mengaplikasikan laser dengan bagus.
Okay, just let me start with a short profile of the company. I don't want to bore you, but I just want to give you an impression what we're dealing with, and that we're quite a global player in our industry. We're a manufacturer, a distribution, and a service company. So it's not about the product itself, but also about catering with the needs after sales, and also if you're on site or do production. Laserworld is a world leader in the field of manufacturing and distribution. We started the business activities in 2003, so it's not super old company, but we're really dominant now in the market. We did high-end manufacturing with one of our subsidiaries already since 1989, and at TAR, probably some of you already know TAR, maybe from 10 years, 20 years back when TAR was really a big brand in the laser industry. They're now in our company group as well, and they started working with lasers in the 1970s. The Laserworld Group has the headquarters in Switzerland at Lake Constance, so in the north of Switzerland, next to the south of Germany, so very close to the border. We have a location in Munich, where we have the logistics hub for Europe. We have TAR Laser in Herne, it's also in Germany. We have Laserworld Asia, we've got an office in Shenzhen with own company and dealing especially with the project business in China from there. We've got Laserworld UK, Poland, Japan, India, Turkey, Korea, Iberica, dealing with a Spanish-speaking market, and several more companies that we don't list here because, you know, we've got some more business going on around the world.
Oke, jadi tapi sebetulnya yang paham bahasa Inggris yang perlu penerjemahan siapa? Yang perlu diterjemahkan siapa? Nggak perlu diterjemahkan ya? Paham? Paham semua? I think they all understand English, so please continue. Are you sure?
Okay.
Ada yang butuh diterjemahkan, saya terjemahkan. Hah?
Okay.
Oke, so they understand you. Nanti kalau memang ada yang nggak paham, langsung angkat tangan aja. Saya nanti bantu untuk jelaskan, oke?
Okay, very good, very good. So if I need to talk slower, please also indicate that I can talk slower. I tend to become very fast in talking when I'm enthusiastic about my topic. So please slow me down if I'm too quick. So let's move on.
Don't look big.
Laserworld sites around the world, I just said we've got different locations all around the world, just showing you some of our offices. This is our main office in Switzerland, the headquarters. No. Laser pointer, you know, laser company, laser pointer doesn't work. Very good. So, yeah, use this one. No, we don't want to damage the video wall. So, yeah, we got business areas all around the world. We got laser manufacturing. We do manufacturing all around the world. So we have manufacturing in Germany, but we also have manufacturing in China, of course, because there are certain product ranges you can only efficiently manufacture in China. But what's important to us is that we do the product development and the design in Switzerland. And we have, as I said before, we have our own company in China. So what we do there is we do quality control independently. So it's our own people doing quality control, what comes out of a factory. And this makes it very, very good for us to control the quality because it's kind of an independent quality control. In Germany, we have high-end production for the high-profile and high-power laser systems that are especially for, you know, really high-profile shows required. We do global sales and we have a global logistics hub near Munich in Germany, but of course we need to cater with areas in Southeast Asia as well. And you can understand that it may be not really efficient to deal from the German hub with here because it's such a long distance. Therefore, we also have a central logistics hub in Asia, in Hong Kong and in Shenzhen. So it's, for us, it's easy to deal from there, even with German-made products from this hub everywhere in the world. So we can cover all the different areas. Here you can see a part of our high-end production. I will show you pictures later. For us, it's not only manufacturing and distributing and selling products, for us it's more. So the laser systems are the central product we have. We don't deal with LED, we don't deal with sound, we just focus on lasers, which makes us experts in this topic because we're just dealing with this specific topic. But there is more around it. There's the laser show design. Many of you are lighting designers. Laser show design fits in that. We have laser show creation, it's a creative part. We have project consulting, so if you our customers have a big project upcoming and they don't know how to deal with it, they give us the plans, the maps, and we help them get going, recommend the proper products, help them really fill the tender for the customer. And this is really helpful. You will see that in different projects. We probably will have some upcoming projects together with asiis pretty soon. So this is something that is very important to us. Of course, laser safety. Different countries cater with laser safety in a different way, but it's an important thing. We'll talk about that later as well. Laser installations, laser dry hire, laser training, multimedia project contracting, laser service maintenance. There's many aspects all around this product, and we cater with all of these. We have different brands that we focus. Laserworld, of course, is our main brand, but we also have RTI. It's the high-end product brand with the high-end lasers. TARM as well, but a bit less powered. Then we have different software solutions like the show editor software, the show controller software, which is the more professional one. We also have the brand of the Laserworld Academy, which is the educational part. And the ShowNet is a new brand that is basically our new mainboard development that we have in our more professional lasers nowadays. We will learn about that more because this is exactly what lighting designers nowadays need to deal with lasers. So, we're heading for the next point on the agenda. By the way, if you do have any questions, do not hesitate to just ask, because I want you to be satisfied and have all the information you want to get after this workshop, because I want you to be able to understand lasers afterwards. Let's have a look at what conventional lighting is. Everybody of you probably knows how conventional lighting works, you know how you control it, what DMX is, ArtNet, and all this. And I want to give you an insight on what this conventional lighting means versus laser lighting in the past and now. So DMX and ArtNet is kind of a trigger signal. You send it towards a moving light, intelligent lighting, and in the past, you used kind of an ILDA connection, which is a 25-pin, like an old type printer cable. Some of you may probably know this, which is not really easy to handle on site when you have a production. And this ILDA signal gave a full analog control signal to the laser system. So what we had was, with a normal lighting system, we have a stupid protocol. So DMX is just a trigger signal. It doesn't transfer any proper information. It's just triggering some intelligence that is already inside the lighting device. But with lasers, it was the opposite way around. So the laser systems were completely stupid. They had no intelligence. There were no mainboards inside. You needed to feed the whole intelligence with this, let's say, bulky printer cable. This made it really, really difficult for lighting designers in the past to deal with lasers because they needed to have completely additional infrastructure to their lighting desk. So you had the lighting desk, you had a computer, you had all this wiring and all that stuff. And it was so annoying that many lighting designers said, no, I don't want to use lasers because lasers are so difficult to use. And now they're not anymore. This is some of the bulky lasers. Probably some of you, the older one amongst us probably know this. This is the gas laser times. It's 20 years back. Huge tubes. There was also water cooling and all this. Lasers used to be expensive. They used to be bulky. They were heavy. You needed trucks. You needed many people to transport them. They were energy consuming. So it was inefficient. And it was complicated to use. You needed a laser specialist on site. You needed special software. You needed to handle the laser safety. It was really difficult in those days. And this all has changed significantly. We have a new generation of lasers now, which are much easier to use, especially for lighting designers that just want to send trigger signals and just want to use the existing infrastructure for dealing with lasers. So, what we can do now is we can send a stupid trigger signal towards the laser. We can also still send intelligence to the laser, and we can use LAN connection, normal network connection, to bring intelligence to the lighting device. So it's a digital connection now. And we can also still use a digital connection to use intelligence inside the device and bring external intelligence to the device. So it became really versatile. This probably sounds kind of funny to you, that you all know how lighting devices like moving lights have this for years. They have built-in intelligence. But as we will learn later, lasers are more difficult in the technology than lighting systems are. Lighting systems are rather simple in terms of the components inside. With lasers, it's sometimes a bit more difficult to deal with the different components, and therefore it took so long for the intelligence to get into the laser. The use of lasers also has changed. Some of you probably know that lasers in the past, when you went to a nightclub, there was one laser in the center, and it was the wow effect. The laser fired up, there was laser show, everybody cheered, yeah, there's the laser. But it was a solitary effect, it was just one laser, or in best case, 3 lasers. Yeah, because they were so expensive in the past days, it was so difficult to handle. But this has changed. We now have lasers as lighting fixtures, and it's so easy to use them in a mass way. So you put up 20, 50, 100 lasers, and you can control them rather easily. So what you can see is that we have not only a normal effect, it's kind of a 5-dimensional effect. You have XY movement, you have patterns that are there, you have movement within the air, you have colors, and all this matches up, and this is all DMX control, outlet control. This is the RTI Neo 6, it's 2 units basically, it's a bar of 6 outlets, and they go well together. You see the different effects, how they work together. This is 72 units, it was in Frankfurt, the show with PRG, and here you see also a batch of RTI Neo 6 units, and it's all simple DMX hardware control. So this was only just one example of what you can do. It was a special fixture, special laser fixture. I especially call it laser fixture. because it is super simple to use and to scale. It's a bar of 6 outlets, you can just use it at the whole stage, just covering it with lasers. This means every lighting designer can control lasers with integrated shownet mainboard without the need of any additional computer. You just plug it in and you get going. And this is exactly what we got feedback from the industry. People wanted to do it, and it took quite a while to develop that because it's not that simple to really have that built into a laser system. We will see that later why this is the case. So now this is just a simple setup I sketched here, how you can hook up lasers to a lighting console. You just have network cable, just have a switch or router, depending on how you want to do the address management, and then you hook it up to a lighting console. And that's it. You just have a profile, personality in your lighting desk. The professional personality in these units has 34 channels, so it's also not a super big profile. It's easy to handle. You can handle several devices on one universe without any problem. So it's a really good solution. But this already became a bit technical. As I promised you at the beginning, I want to give you an insight from a designer's perspective as well. Not only talking tech stuff, but also having some visuals for you. It's time to do that now. But before, we need to understand what lasers can do. Because laser show or laser projection is not always the same. There's different ways of using lasers. And this especially comes from the way the audience looks at the laser. Probably you haven't thought about that because in many cases lasers are just used as a projection, or you look into the laser but you actually probably didn't think about it in special. But what you can see here, we have different ways of doing it. We have the front projection. This is just a normal projection, and the spectators look towards the projection the laser does. But we also have the rear projection, where there's kind of a rear projection screen where the laser comes from the opposite side, but it doesn't pass through the screen. And there is another option, which is a translucent surface, like a gauze screen or mesh screen you can use, which is a really cool effect. I like it, because you see the projection somewhere in the room, but the laser travels through it. This creates kind of three-dimensional effects, and you've probably seen it at several shows. This is how 3D effects can be created with lasers by using these kind of translucent surfaces. You also have a way of atmospheric beams. This requires really high power because visibility of lasers using this perspective is rather bad. But it's used for outdoor beams mainly. And then you have the classical beam show that you encounter in nightclubs or at festivals, where you just are faced by the lasers. Audience is faced by the laser. It's also the most dangerous application of laser, but hey, we see later how we can deal with it. You've seen in the sheet before that lasers always need some kind of surface to be visible. So we can either have a solid surface to project on, or we can have kind of particles in the air to reflect the light. So it depends on which perspective you have to the laser. If you have a beam show where the beam should be visible in mid-air, you of course need to have some kind of particles in the air so the laser becomes visible, because light itself is not visible if not reflected. And this is very important. So you need to take care that it's sufficient kind of fog or haze or mist or whatever in the air. You can use really high-powered lasers, and normally the pollution in the air is sufficient, but these are dangerous lasers, so for nightclubs this is not a solution. You can also use projection surfaces. If you have a projection situation, projection screen, gauze, mesh screen, or a wall, or a statue, or whatever, building, there's many options. This is just up to your imagination. For audience and beam shows, it's really sufficient to have, really essential to have sufficient fog or haze, otherwise you will not see it. Even if you have an underpowered laser and you think, oh, I've got too less power, you can still use fog to make it better visible. And this is just a recommendation from my side. always take sufficient fog machines, especially if you're outdoors, if you've got a festival or something. Take at least 3 times more fog machines than you normally take, because you will need them. And it makes the show outstanding, I can tell you. It's great. And it will be disappointing if you just have 1 fog machine at the stage. You will be disappointed. You can have really strong lasers, but it will not be good. Not every type of laser show can be controlled the same way. You need to determine which is the correct way, because lighting designers tend to make it easy. Say, oh, I hook it up to the lighting console and just use the internal memory and just play that. But you know, if you want to do a graphics show, this is really difficult, because you don't have the abilities with just a trigger signal from the console to really influence on the content. So sometimes it's not necessary. I don't want to blow the speakers. Good. So for live productions, ArtNet and DMX control normally is fine. And most applications you guys probably cater with are live productions. And so normally this kind of control is really good. You can also decide to either trigger the lasers directly or to use the software in between. So you can still use the intelligence of a computer and just trigger the intelligence of the computer. So there's different ways how you can actually control the lasers with ArtNet and DMX, because it's the direct way and the indirect way. Both have pros and cons. If you want to learn more about the pros and cons, I encourage you to just talk to me after the presentation, and I can guide you to the different things you probably need, because there's many things you can do with it. If you have more than 10 laser systems, so it's no solitary effect, as I said before, it's best to just go with ArtNet and DMX, because it's too complicated to just fumble around with the software. So ArtNet and DMX is the way to go if you do big shows. But there is other applications for lasers, like music synchronous shows, which means you have a soundtrack and you have a synchronous show to this music. And this, of course, is difficult to do with ArtNet and DMX, because you're so limited in the features you can call from the lasers. So it's best to use laser software for it. Architectural projections like mapping things, of course, as well, because they are rather difficult to handle, and you probably need to do geometric corrections on site, and all this is rather bulky to handle with ArtNet and DMX. Now let's think lasers from a designer's perspective. Open your mind for new ways of creativity. So it looks good in original, not stacking, but in this case, what you see here is also text projection. It's an advertising application now. It's in German, but this is an application for outdoor. This is kind of an artistic thing, but also mapping projection and using lasers in a way that you cannot do with it. So, just to give you some more impressions about multimedia applications with lasers. So what you see here, for example, on the upper left corner, it was a corporate event, rather small corporate event, but we combined a video projection with laser outlining, you know, make the logo of this company stand out with lasers. On the other side, it's kind of a theatrical productions with lasers, and also with hydro shield. So this is another thing that's quite interesting, combining lasers with water effects. This is just a water wall, and this is a so-called hydro shield, so it comes up from the bottom, folds up, you can project on, and if you just stop the pump, the screen is gone. The other way around would be a water stream, which comes from top to bottom. This is another application. It's a projection on water surface that you can also use. This was Shanghai Expo, I think it was many years back, inauguration of Shanghai Expo, and you can also use fire effects combined with lasers and water in this case. And there is more multimedia effects. You can already see the preview picture. You can imagine what happened here. We have a wall of lasers behind this artist. So this artist.
Nah, ini dimatiin.
This is a multimedia installation that happened in Bird's Nest in Beijing, where you see there is a projection with lasers, but also emphasis with lasers on the water shields. You see the hydro shields, left and right. There's lasers projecting onto the hydro shields, and also now emphasizing the stage. Some artistic application in theater, using lasers emphasis for the artist. Also some hydro shield projection. This is a water screen, so water falls down from the top, and this is a mapping projection. So you've seen there's many things you can do with lasers in a multimedia context. Just thinking out of the box, outside of the box, just rethinking how you can combine different media together. You are the artist, I'm not an artist, I'm more from the technical perspective, but I try to give you some impressions what you can do, and I think there is so many ways you can utilize lasers. You see another way here. This is a so-called, in China you call it landmark laser, but it's basically a high-power outdoor application of laser. What you see in the left picture and the top right picture, it was in Marseille, in France, a connection of 7 cities that were connected by laser beams, and they were quite far away from each other. And we used really strong laser beams. It was a 40 and one, even 72 watt single green powered laser, which is extremely bright, to connect these cities. And the bottom right, you see, this is our headquarters, our head office in Switzerland. We used some lasers to shoot across Lake Constance, which is the largest lake in Germany and Switzerland, which is just in front of the office. So we just used it to shoot over to Austria and Germany, which is the countries that are just located on the other side of the lake. If you know this building, there's quite some high power lasers in place. It's 31 units usually used for these effects. It's Shanghai Expo 2010. Also projection of water surface. This is on the lake in Bavaria, where we just tested a new product system. You can see how efficient it can be. This is the beam from the head office. This is in Marseille. And this is in Bangkok, Thailand. It's our Rama 8 bridge. We did an installation some years back. This is just the view from the lasers, and this is the opposite view of the bridge in Thailand. But these are kind of very sophisticated applications sometimes. Not everybody caters with these kind of productions, because everybody has their niche to deal with normally in lighting design. So I just want to give you an insight also on nightclubs and festivals, because lasers, they are very famous from nightclub use, because everybody knows them from there. Not everybody gets the chance to see a high-profile multimedia production, but everybody knows it from the nightclubs and festivals. So I still brought some video footage from the recent nightclub shows and festivals. Just have a look. This, by the way, is all controlled with ArtNet and DMX here at the moment. This as well. This too. This also. This as well. I've been to that event. It was spectacular. see is lasers in this context are emotion. And this is an important thing, especially if you work as a lighting designer, because recently it was very fashionable to have huge LED screens, you know, huge LED panels, which is cool. I like them because you can give a message there, you can give information there. But if you have a huge LED screen, everything is bright. And it's just an ambient light you create. It's not an emotional light. Because if you have normal spotlights in a nightclub or at a festival, this is light that touches people because it goes into the people and people experience the light. It's an emotional thing. So, lasers are exactly the same way. You can use them to emotionalize people and get the vibes to people. You can transport the message of music, of an artist, of any kind of message you want to transport in an emotional way. And this is something that is really different to an LED wall. Probably you have experience, if you have a nightclub situation, people rather dance if it's not too bright. Because if it's too bright, they probably get ashamed, they don't want to dance, and if you put up fog, it's even brighter. But if you find a good combination of LED wall, profile, wash, and lasers, it can be an extraordinary night for everybody. So, we've talked about the designer's view on lasers, or the potential view on lasers. And now let's have a deeper insight on how lasers work. Because it's important to understand how lasers work, to understand what you can do with them, because the potential comes also from a technical perspective. So, how do lasers work? Why are they different from conventional lighting? And what are the opportunities of lasers? And what are the limitations of lasers? Basically, laser light is extremely focused, and we have a very high density of energy in one spot, which is something that is pretty cool, but it's also pretty dangerous. Laser light is also primarily focused by the way it is created, not by additional optics. So if you have a spotlight, let's talk about Sharpies, super Sharpies. Everybody knows them? Really, the focus spotlights. This focus light is created by optical means. So you have a lighting source that more or less emits light in a radial way, and there is optics and deflectors that focus the light. This focusing of the light is rather limited because there is a certain physical limit how far you can focus it without making it kind of, focus in one point and then spread up again. With laser it's different because laser is created in a different way. It's already created in a directed way. So, from the atomer base, so really on the atomer base, speaking from the atomer base, it's already directed. You can see we have radial emitting light, normal light bulb, it emits in a radial way. So the whole energy from this light is distributed to a rather large area at a very short distance. With laser we put in only a minimum amount of energy, and this energy is preserved over a really long distance because the so-called divergence, so the widening of the beam over distance, is really, really low. And that's why lasers are so efficient, especially if you have to make light travel over a long distance. Outdoor festivals, inaugurations, outdoor applications with architecture projections and something like that. And to emphasize why laser is a focused light from the beginning, laser stands for light amplification by stimulated emission of radiation. And the stimulation in this creation of light is what makes the laser travel one way and very directed. So I just made a comparison of how light and lasers look like. You have a Sharpie on this side, which has a very narrow beam already, and it has a really low divergence, but it's got quite some diameter. So you still have the diameter of light, but it keeps the same diameter over quite some distance, but it ends after, let's say, 50 meters or so. It really dims down, so you don't have any visibility in that effect anymore. But with laser, the intensity is preserved, not only over meters, over kilometers. And this is the effect you can use and make use of for lighting design. How do you find the right laser for your application? Because we spoke before, there's different applications. You have nightclub scenario, you've got festivals, you've got installations, mapping, architecture, so many different kinds of applications of lasers. But how do you find the right laser? Because there's so many different varieties of lasers available. Very cheap ones, hey, you can buy one for really a few bucks for your garden, but not for professional production. But there's others that are super expensive, but you don't need them for a nightclub. So how do you determine the right laser for your system? So lasers may look similar. So there's many lasers available or are in black boxes. But like with lighting fixtures, all that matters is inside. So it can be the same box, but there can be different interior. And many technical aspects can make a difference in the quality of a laser systems. The technology inside is decisive, and some very important thing, do not fall for the total power thing. So there's people that come up and say, oh, I want to buy a 3-watt laser. But you know, this is not how you buy a laser basically, because do you buy a sound system, a professional sound system, by going to the shop saying, I want a 10,000 watt sound system? You don't do that because you want to listen to the quality and you also want to listen to the efficiency. So it's not a matter of how much power the sound system consumes, but how much dB comes out of it and what the quality is. So this is what you do with sound systems. So do it with lasers as well. With lasers, there's many aspects that are more decisive than the overall power. Because the overall power with laser system consists of different colors. And different colors are perceived in a different way by human eye, which affects visibility a lot. Let's have a look at just a general sheet, what the technical specifications for lasers are. I just want to go quickly through it. We have the total power and total power aperture. Total power normally is the addition of the power sources inside. And then is power at aperture, which is the actual power that comes out of the laser, because there are so many optical losses inside, because the internal components are combined by optical means, which may lead to certain optical losses. Then we have the powers per wavelength. Why do we have powers per wavelength? You don't have that in a moving light. It's just white light, and you put some gels in front of it, and then that's it. Then you get the color, but not with lasers. With lasers, you have 3 different color sources inside. With most lasers, there's some specials, but with most lasers you have RGB as sources inside, because laser light is only created in a certain small bandwidth of wavelength. So you have green lasers, red lasers, and blue lasers. But you don't have a white laser, because the white we create in these lasers is created as a mixture of RGB, like you have in the old type LED power cans. The first power cans that came out, you also had the same thing. You had RGB, and that created white. But this is more professional, of course, in the lasers. And we combine red, green, and blue to white light inside the laser, and therefore you have different power values given. So in this laser we have 200 milliwatt red, we have 200 milliwatt green, and we have 600 milliwatt in blue. So you can see it's also not equal. Why is it not equal? Because this has technological reasons. The laser sources have different maximum possible powers per laser diode. It's a rather technical thing, but this means that we only have 1 diode in blue there, but we have 2 diodes in red, because red is limited in power. It's rather limited, and in green as well. So this makes it difficult, but when determining the visibility of a laser light system, The green portion is decisive because you see this chart, and what you can see is this is the visibility chart of colors to human eye, and it's very important to consider that. Probably many of you know this already from the lighting design because it's an aspect of lighting design. If we use green or this green-yellow color, it's best visible. But if you come closer to the, I just do the sporty thing here. If you have a look at the blue, for example, you have a deep blue and you have a lighter blue. And this deep blue, the light blue is 3 times better visible than the deep blue. And here the same with the red. You have much better visibility with just a difference of very few nanometers. And you can see that the visibility of blue is down here, of red is down here, and of green is up there. So, if you really want to determine the visibility of a laser light system, compare the portion of green with each other. Because what you can do is reduce the other colors. So if you make a mixture of white and you have too much blue, you can reduce blue. But you cannot add more green. It's like with the hairdressers. If they cut off your hair, it's gone. But you cannot add more hair. It's not possible. So that's it. So down there you see the different wavelengths for the colors. By the way, we're getting very technical now. If you want to get this presentation after the show, we can send to you by email. So just give your business card and your details to Milan. It's the tall guy over there, you can't miss him. And we will send you the presentation afterwards by email so you can have a look inside and just make your mind up again. So as I told you, the power per laser source is rather limited. That's why we have some technical challenges to deal with when building laser light systems. And this is a laser module like it is built nowadays, more or less in this type. And you see the small laser diodes up there as well. Just pop up here again. So these are some laser diode samples, the single diodes. But for example, for red, as I said, we have maximum 170 milliwatt per laser diode. So what to do if we need more power? We need to combine them by optical means. And this is really difficult because you can have these laser diodes in 2 polarities, and these you can combine. This is no problem. You can do that with a polarization cube. But if you want to combine more than 2 diodes, then it becomes tricky. Then you need to do the so-called knife edge combination. And this is the schematics I've put up here. So we have the diodes with polarization A, with polarization B, and they are combined with small mirrors, and they are put very, very, very close together, and then they are put up to one beam. And this is how we create higher powered beams with red, blue, and green if we need it. As you can see, this requires quite some precision. If you want to have 30 watt, for example, of red, can you imagine how many of these diodes you need to combine if one has only 170 milliwatt? This is huge. This is many, many, many diodes you need to combine. And this makes it difficult to really build high quality, high power systems. Why? I will show you that. Because the powerful lasers can only be built with optically combining them, and the challenge is, and this is the major problem we have, that the more diodes are combined, the thicker the beam gets. Of course, if you put them together with mirrors, then the beam gets thicker and thicker and thicker. But the problem is that if you have a thick beam, you require big scanner mirrors. What are scanner mirrors? Why are there mirrors inside? I tell you. The scanner systems inside the lasers are used to quickly deflect the laser beam to create an image. This is something unique to lasers. It's not like in a moving light where you have a gobo that you just shoot the light through and you have kind of a static image somewhere. But with lasers you can create dynamic imagery, and this is created with these 2 mirrors with motors, and these mirrors move very, very quickly. But as you see, it's kind of a mechanical deflection. It's not like in old TVs where you have these kind of brown tube inside where it was electronically deflected, but it still flickered. But here we have the challenge that it's a mechanical deflection. And you can imagine what happens if these mirrors become bigger and bigger. The whole system slows down because the inertia, so the torque is not enough. The inertia of the mirrors makes them wobble and not move that fast anymore. So we need to have very small beams, to have small mirrors, to have a proper performance for the imagery we create. The quality of the laser beam directly influences on the quality of the scanning. That's it. So as you see, there is quite some challenges when building good quality laser systems. You cannot just mount things together and hope it works. It doesn't do. There is a lot of technology behind. There is optics. As you see, we have to consider a lot of optical things. We have electronics, and we also have metalworks, because we need to consider that temperature can change the way the beam is created, because we have so thin combinations with the small mirrors and only centimeters. So yeah, extremely small deviations can create the beam to be kind of split up. That's why we need to really consider proper metalwork as well. So I've just talked about the technology, how lasers are created, and how the general technologies behind or inside laser devices. This is something I've introduced to you at the beginning, and this is the new main board I'm talking about. This is the show net. We have this in all our new laser systems, and this provides the intelligence inside the laser. So we've talked about the technology, how to create the laser light, and this now is the intelligence we put into the laser to actually be able to be controlled with ArtNet DMX, sound to light, automatic mode, master slave mode, and software. And it's even possible to do ILDA streaming, which is a special thing for laserists. They want to do that sometimes, but probably not important to you at the moment. But what you can see, there's many features down there that a proper lighting designer wouldn't use, like sound to light operation or master slave operation. But this is important for nightclubs, for small DJs, for entertainers. That's why the products that are designed for these customers also have the option to be operated that way, because it's legitimate. If you don't have a lighting operator on site, you need to be able to get going with lasers as well. That's why we have these operation modes in the lasers as well. Questions regarding the technical thing of lasers? We will have an in-depth view on the laser system itself in a bit. Now, so I prepared, I opened this laser device, and to show you something I put up a camera. So just need to improvise a bit with a microphone. Maybe you can see what's happening, what I'm doing. Maybe you can already identify the scanner system here at the front. So this is the point where the laser beam is deflected and where the imagery is created. You see it from the interior, and I just get the angle where the beam comes from. And this is deflected to the outside. And you can see the two mirrors, and they create the image. Then we're moving back from the front to a deflection mirror here. And this mirror deflects the beam that comes out of this module. And this is the module where the different colors are built in. I just have a closer look at the opposite side. switches. So what you can see is the different single laser diodes inside. So there is different colors, and they are all optically combined inside this module. And this is where all the magic happens. So this is the laser light creation, and this is the imagery creation. This is the scanner driver, so you can make adjustments on how the image is created so that it properly displays. And we have here, you see the board with the red connectors. This is the ShowNet main board. You can also see that there is an SD card. No, you can't see it. No, you can't see it. Yeah, now you can see there is a small SD card, and this is the internal memory where you can store your own graphics, animation, and content on. Every of these laser systems with a ShowNet inside already comes with a free software that allows you for creating your own artwork. You can also import own logos and graphics to it, and you can create own artwork, load it to the laser, and then trigger it by DMX or ArtNet later. Which is really, really cool because it allows you for a lot of creativity. Let's have a look at the more powerful laser system. This one is a 10 watt system, the other one was a 2.5 watt. So this one is a 10 watt system, and you see that the laser module is a bit different. We have the different colors. So at this mirror there's the green color coming out, here's the blue color coming out, and here is the red color coming out. And you probably wonder, how do these match up? Because they should be white. We have a look, I'm not sure if you can see it. You see that it shines in a certain color. These are so-called dichroic filters. So it's an optical filter that lets pass a certain wavelength and deflects other wavelengths. So this way you can combine. This one is just a normal deflection. This one, the green one, and these are dichroic filters. And latest here at the deflection we have a white beam if we go full power on all colors. Then we have the scanning system down here. Yeah, and that's it. And this is a 10 watt system already, so you can imagine it's not a big bulky unit. You can handle it with one person. The same is, by the way, for the 30 watt system. It's also not that big. So it's a one person handling unit. So to have a closer look at lasers also means to have a look at the back of the lasers. And let's have a look back on the laser. You have different connectors here. So we have a network cable already connected to the ShowNet, which is the internal mainboard. So we have a network connection. We have the key switch, and we have the so-called interlock connector. In this case, I've bridged this interlock connector. You can also attach an emergency stop unit here. Why do we have an interlock connector and a key switch? You probably ask yourself, because it doesn't make any sense to have to make sense. This regulatory comes from the industrial lasers, because industrial lasers, they need it. So there is no unauthorized use of the laser system if somebody leaves the operation stand. That's why they have it. It's the same international regulatory for laser systems for industrial lasers as for show laser light systems. Okay, so let's move on to laser show control software. Laser show control software probably is somehow irritating to some of you because you want to control with ArtNet and DMX, and this is fully okay. But there is reasons when you need laser control software if you want to go more into detail and want to do more sophisticated stuff. Not just triggering, but creating artwork, creating artistic shows. So there is one software that comes for free with every laser system that we sell with a ShowNet. This is Show Editor. It has full features, so you have live operation mode, you have timeline mode, you can create your own artwork and save it as ILDA file to use inside the lasers. So it allows for a lot of creativity. It's a free full version, and it also supports timecode, which sometimes is important to lighting designers for large-scale productions. You can create all the artwork you want to do. Of course, this one is not the top professional software. It caters for all the basic use and is really good to use. The timeline programming uses the logics of audio recording, so not everybody's familiar with audio recording. This sometimes makes it difficult for people to use the timeline feature, but we have a professional software as well, and this is the show controller with the different tools coming with it. So you can create even 3D laser graphics with it. You can live control it, program timeline shows. You can convert JPEG bitmap images from logos from clients, for example. You can convert them to be able to be displayed by laser, and you can even get 2D and 3D animations from Blender into the software, like vector graphics import and even vector animations import, which is important if you want to do really high sophisticated mapping things or corporate productions. They sometimes require stuff like that. So with this software, you're ready to go. There's also a professional visualizer there. With Realizer, you can also do more sophisticated visualizations as well. Regarding the software, after we finished the workshop, I will bring up some software and encourage you and invite you to just have a look how we operate the laser with the software. I will beam somewhere and I can show you how things work, so we don't need to do this all together, but people that are interested can just join me and I'll show you all the tips and tricks and give an inside view on the software. Let's talk about laser safety. Laser safety may be irritating to some of you because lasers are in many cases just used as they are. Lasers firing around. If you've been to exhibitions in China, you probably got lased big time because they just don't care there on these exhibitions about laser safety because it's they just go. In fact, I don't know of any bigger accident that happened in the past years, which is an interesting aspect, but of course there is regulatory on laser safety, international regulatory, but not every country really enforces it. But it makes sense to have heard about it, because then you can make sure that nobody gets harmed at one of your events. But nobody of us here wants to harm somebody at the event and then be liable if there's any problem afterwards, because this is something you don't want to have in the industry. It's always required to make a risk assessment, just to make your mind up what can happen and if there is any issue potentially. Normally, there is no license required to do laser shows. There is only 4 countries I know of that require a license, which is Germany, Austria, Switzerland from next year on, and Singapore. I don't know of any other country in the world that requires a laser show license, but nevertheless, it makes sense if you familiarize yourself with the basics. A typical requirement is mounting at 3 meters height, so nobody can access the laser, because you can imagine if somebody grabs the laser, turns it down, people look up and then just get hit by the laser. Because if somebody comes towards you, you tend to look up, and this is a dangerous thing, so nobody can manipulate at the laser at 3 meters. It can be adjusted, of course, if nobody can access the laser. You know, if it's just on the stage and nobody can get close, of course you can put it on the floor. There is a term which is called MPE, maximum permissible exposure. This is the maximum output power allowed in the audience area. And there is the name of an international regulatory which applies all over the world, where all these details are written down and kind of standardized. It applies all over the world except for America. The US, they have kind of different weird stuff. The power of a show laser system significantly reduces with the distance of the audience to the laser. You can imagine what we do. We have a single beam inside the laser, and it hits the scanners and it gets deflected. So what we do is we have a portion of light, 1 watt, and we distribute this portion of light to a larger area by scanning. So the beam, it's only one beam, it moves very, very fast, and it creates the imagery that we can see. But by doing this movement, it moves so fast that the laser doesn't remain on the eye for a long time. It's just for a very, very short time, so it cannot make any damage to the eye. So if you can imagine, if you're close to the laser, the circle is rather small, and you get hit pretty often by the laser light. If you go far away, the circle gets bigger, so it takes longer time for the laser to return to your eye, to move over your eye. So by getting a bit of a distance to the laser, from the audience to the laser, you increase safety a lot. Of course, if you shoot single beams towards the crowd, this is dangerous because there is a huge difference between the use of laser for doing spot effects than for conventional lighting. If you have a moving light, a spotlight, and you want to have a really thin light beam, you can use a gobo with a small hole, and you get a thin beam. But what does this gobo do? It cuts off the rest of the light and just lets pass a certain portion of light. With lasers, it's different. If you make a single beam, all the power that's available goes into this single beam. So it doesn't take a portion of the power, it takes full power. So every output you have from the laser uses the full power if you do not manipulate on that. So if you make a circle, or if you make a car, or if you make a triangle or a spot, it's always full power. It's just a matter of how you distribute the power over a certain area. That's to be considered in terms of laser safety. So if you want to make laser shows safe, basically the first thing is get a bit away from the audience and do not make single beams, but kind of distribute the power to a certain extent. This is the most important thing. If you consider that already, it's always halfway through of safety. Internationally spoken, not regarding the MPE because this is very low, but just to know that nobody gets harmed. To understand the risk of emitted radiation, lasers are divided into 4 classes. You probably have heard that. There is laser class 4, laser class 1, and this is the laser classes that are specified at the moment. Probably some of you don't know laser class 1C. This has been released recently. It's for medical lasers. But this is the laser class available, and I just wrote the maximum powers that are specified for this classification. So if you have a class 2 laser, it's maximum 1 milliwatt in power. If you have a class 3R, it's maximum 5 milliwatt in power. And if you got 3B, maximum 500 milliwatt. And class 4 is everything above and everything unspecified. And in our industry, we usually have class 4, which means it is considered potentially dangerous. There is funny things that can happen with lasers because we're talking about 10 watt, 2.5 watt, but to give you an impression how dangerous lasers are, just an example. What power do you guess you can light a cigarette at a laser beam? And this is a quite interesting question because everybody can imagine what it means to light a cigarette. It needs quite some power. But with lasers you need 400 milliwatt only to light a cigarette. We can probably show that later when we have the software on. So if somebody has a cigarette, I can show you how easy it is to light a cigarette with a laser. And you can imagine what that means to a human eye. And that's why there are the regulatory in place specifying it's very dangerous. It can also be dangerous on stage if we've got some flamers here, some flame jets that have, these gas cartouches that are probably painted black because if they're kind of fancy colored on stage, they don't look good, so you paint it black, got black gas cartouches, and you have a 10 watt laser just next to it and it just points towards the gas cartouche. What happens? Boom. So this is something that can happen, so use them responsibly, but it's like with a chainsaw. If you know how to operate it, it's easy. So that's why I don't want to scare you. It is easy, nobody got harmed in recent years. So let's talk about laser safety areas. This is just something from the regulatory I want to show you. I've already said that it's a minimum mounting height of 3 meters, and it's also that if you need to consider if the audience seating gets up and gets elevated in the back of the venue, you also need to consider that when shooting hot beams towards that, because the power of the laser is preserved over a long distance. So even if you make a single beam and you have a venue that is 50 meters, it can still be that there is the intensity of the laser beam is still as strong that people get blinded, because it's preserved so much over distance. Of course, the beam widens up a bit, and human eye cannot take the full portion anymore, but it's still a dangerous thing. Oh, by the way, not only lasers are dangerous this way. You can imagine if you have a spotlight like a Sharpie, Super Sharpie or a similar product, and you get hit in the eye from close distance, you get blind anyway. So it's the same effect. Just the light from these units is not as efficient as a laser. That's the difference. So, if the limit of allowed radiation won't be exceeded, the laser is used in a safe way. The distance is one of the most important variables for this topic. So if you don't have any regulatory in your country regarding laser safety, it's already a good move to just consider having certain distance and not shooting hot beams into the audience. But there is more ways of reducing the danger of the risk of harming people by using software. So if you have a laser software, this is the professional software, but it also goes with the basic software, we can put so-called safety zones or so-called beam attenuation, where this is areas where you can reduce the power of the laser. So you can say, okay, I want to have a horizontal safety zone. It's like this one here. So this one is the horizontal safety zone. So below here, the power is reduced by the amount I set up here. In this case, it's only 40% of the power down here. Up here is full power, and here in between is a transition. So it's not a kind of a harsh effect, but it's kind of a smooth effect. So people don't see too much that you have reduced the power in that area. I will show you that later when we do the software thing. It's a bit delayed. This happens with ArtNet and DMX as well. So we implemented a DMX profile in this unit that allows you to also set safety zones, at least horizontal and vertical safety zones via DMX and ArtNet, which is super important. Can you imagine having a stage with, like in a festival, with 40 laser, 50 laser on stage? You cannot control them with the software anymore. It's not possible. You need to use ArtNet or DMX for controlling it, or any other trigger signal. And then you need to do the safety zones, because otherwise it will be too dangerous, probably with the high power lasers. And that's why we implemented that to the DMX profile as well. So, risks are to be respected during operating or installing the laser projector. So, the most dangerous time you have with the laser is when working very close at it. Setting it up, aligning it, repairing it, then you're close to the laser. If you've already mounted it, it's kind of a controlled area where you already took precautions and normally nothing happens. So if you work at the laser, do not use reflective tools. Do not wear jewelry, like watches, like rings or something like that, which I do now, which later on we will see it's dangerous. Do not bend over the device, because there will always be laser radiation coming up from the scanner mirrors when you work at the running system. Make sure that the laser does not start automatically when mounting it to the truss, because these lasers, they also have automatic and sound to light mode for basic operation, like for DJs and stuff. So it's possible to just let them run. But if you hang it to the truss, you're likely, you're on the ladder, you have the truss, you plug in the power, you turn the key, you put the interlock in, and then you're faced with a laser because it flashes into your eyes because you're just in front of it. So this is very important to consider. Just make sure to not blind yourself because you're so close to the laser. So then there's also the chance that you have inexperienced people that can do the same thing. People inside safety areas, and of course try to avoid lasing cameras, projectors, screen, because they can also be harmed. Even easier than human eye, because they have kind of lenses in front that focus the beam and then they burn the sensors. Okay, this is it in brief about laser safety. I'd like to have a closer look at the Laserworld product portfolio. We just talked about the different aspects, what you need to consider, what's about with the lasers. But I just wanted to give you a short overview of what kind of products we do cater, because there is so many different applications of lasers which needs to be considered on the product side. This is pictures from our manufacturing, our high-end manufacturing in Germany. You can see it's quite a sophisticated way of dealing with the laser stuff, especially in the right corner you see the electronics, which is specially made, very efficient electronics for OPSL technology, which is a really high-end technology for certain kind of multimedia projects. These products are usually used. This is an overview over the product portfolio we cater at the moment. So we have the consumer level products at the top, which are rather basic units. It's not meant for professional use, but it's okay for, you know, small nightclubs, for DJs, for entertainers, just for beginners. These are the right products, and they are very, very affordable. Then we have the semi-pro units, which are meant for beginners and also smaller nightclubs and people that just want to start with laser but do not use it in a professional way but just want to get going. This is just to experience lasers, and even the diode series is already used for professional applications, because the diode series has the latest technology with diode laser sources. So these are already used for professional applications, nightclubs, installations, but they're very, very affordable still. So it's really an affordable product range. Then we go up to the more professional units, like the Pure Light series we have here and the Charm. These are the two units we have here. So we have a 10 watt from the Pure Light series and the Charm 2.5, which is a really, really good product. I like it very much, and I own myself. I bought some because I like them so much, just to play around with them. And we have some high-end units, which is the RTI Nano, Pico, Neo 1, Neo 6, the ones we saw with a multi-beam effects, and also the higher powered TARM units. So as you can see, it's the full range of products from the very low end to the very top end, and we're probably the only laser manufacturer that really carries all these different aspects of product, which makes it easy for us to support the exact correct solution for your application. Because if you let us know, or let your local partner know what you want to do, we can suggest the exact right product for this kind of application you have. Because these products are different in power, in beam quality, in scanning quality, so it all depends on what you want to do, and we have products in all price ranges. But there is more to lasers than just the product, because it's important that if you go on a professional production, you can rely on the product, and then you also can rely on the after-sales service. So what we do is we have a 2-year warranty on the products. Special conditions may apply to certain products because there's differences in products. We have the service centers in Munich. We have one in Shenzhen, which we can also cater from Hong Kong. But we also have local partners all around the world that cater with the local problems. So, for example, in Indonesia, if you would have an issue with any laser, you know, it's not working, something's kind of misaligned or something like that, you can probably just go to Pak Andi from asiis, and they can help you, or you can go to your other partner, local partners, because we help them get going and establish local service points to really be straight at the customer and be able to help short term. We do have a 100% QC, as I said previously. We test all of our products, which is important because they are all CE certified. And it's not only a CE certification that is done by the company saying, hey, we are CE certified. No, we do this with an external expert company that does all the tests and certifies it. We need that because it's mandatory for us in Europe. Otherwise we couldn't import the product in a legal way. They sometimes make checks, and as we are at a certain size of company already, they checked us, and we were safe, but others not. Okay, this is it with a presentation from my side. Do you have any questions? Anybody any questions? No questions. I encourage you to just join me now here and have a look at the lasers, hands-on, have a look inside. I will fire up the lasers with the software now, and you can also have a look at the software. And if you want to receive the presentation, find the tall guy and hand your business cards and your details to him, and we will send you the presentation afterwards, probably beginning of next week. If you have individual questions, just feel free to come to me, to ask me. I'm around here, and I will be later at the asiis booth over there, and also tomorrow in the morning, so just feel free to ask me or Pakandi for further details on the lasers. So thank you very much.
Produknya yang ada di sini bisa lihat ke depan. Mari. Kalau ada yang interested untuk melihat jeruannya, ya.
Ke tengah. Bu, di sini aja, Bu. Di tengah aja, Ibu.
Bertanya-tanya ini secara pricing gimana ya, sama harga gimana? Ya, sebenarnya kalau kita ngomong Laserworld ini, karena tadi juga ada beberapa klien kami yang sudah sempat menanyakan, dan dia sudah menanyakan juga ke perusahaan lain yang bahkan perusahaan bukan dari brand Eropa, harganya masih sangat bersaing. Bahkan 10 watt kita pun lebih murah harganya daripada yang 8 wattnya brand dari perusahaan lain.
Banting banget ya.
Yeah, that works out. Here we go. Okay, you see, there's a visualization of what I do, and there is also the actual projection. And you can see, by the way, there is haze now and fog, and you can see how the beams actually really look inside the fog. You either control this one with a computer only, you can hook up a touch screen, you can use MIDI consoles with it, but you can also remote control the software with ArtNet. Use the faders of your console, but you have the full features of the software, which is a huge advantage because you can make writings, logos, etc. I just show you, I just use some free banks. There are effects later with ArtNet as well. So if you hook that up to your console, you can also control rotation, zoom, and all these effects later with ArtNet as well. But if you just want to use it here and want to pre-program it, it's no problem. Just add rotation. In this case, I just want to put some advertising up for asiis. So I want to create own artwork. In this case, I just want to do some text because text is sufficient to represent asiis. I just click here and I say asiis. That's it. I have the text. I just put it to the correct position like this, and then I send it to a temporary buffer. Go here and I want to use it here instead of this, and just load picture from temporary buffer, and there it is. And here we have asiis rotating. So you see, it's super simple to get going quickly, to use it for advertising purposes, to use the speed. I can edit it again and probably add some sparkle effects. You see the sparkling? So it's simple. It's really simple but very effective to use. Yeah, but you know, now we have the situation, there is an audience, and we don't want to hit the audience with a laser full blast because it's too strong. We assume we have a too strong laser and we need to reduce the power for the audience, so we use so-called safety zones. we can read. So this works pretty well, like this. Okay, but we want to have a safety zone. So I go to safety zone, and I can specify the zone here and also the transition area, and then I can reduce the power. Now the problem is that where is it? I got a very small projection, that's why it's all done. Yeah, now it's half gone. You know, this laser has been set to be used upside down. That's why the safety zone now comes from up, but we want to have it down, so here we go. Here we go. So now it's right side up, but of course we need to position it, adjust the power a bit. And you see, depending on the color, it looks differently. But let's have a look at the same thing with a different pattern, just to give you a better impression of how it works. Let's have a white pattern. And you can already see that something is different, because the lower part is reduced. You can see how much I can reduce it. And this is how you get safety to your shows, because you can really run the show full blast at the top, and you can have low power at the bottom. Let me show you some more things, because I really think that there is some people amongst us that really do high power festivals, you know, really club stuff. So you want to use lasers the proper way, I assume. Okay, good. So let's have a look what we can do. There is a so-called thing that's called beam table. Beam table means that this is single beams, and this is a kind of a table where the single beams are marked, and you can specify these single beams. And if you come to a new venue, you just adjust these single beams, and all the patterns you program automatically adjust to these beams. So if you have these beams set up once to not hit the audience, you can also adapt it to a new venue with only adapting this table, and you don't have to change every single pattern. It's just this table, because the beams are moving the proper way. So I just show you this one. It's just a simple thing. It's just me clicking through it. I do them to white, so we have proper white beams. Too quick. This is it. So we have proper white beams. Here we go. So this is the white beams, the 3 white beams I want to use now. And I want to use them. Here you see GHJ. I can use them on the keyboard, and I want to play them pretty quickly. So in this case, I just want to put the static beam. Oh, in this case, we don't put that because it's not a good idea to put that towards the LED. I just reduce the power a lot. We will show that later on in a different way, because otherwise it might be difficult. So again, we put that up. We put it to the full length. This is the beam 1. Then we have the beam 3 in this case, because it's the center one. And we want to have it as flash button. So in this case, we just put the flash only to on. Here we go. And we put a static beam, and this is the 3rd one. So to the right, we put this one to full length. So what we have now is kind of a beam sequence we can run. I just check where we are. We're too dim, I think. Yeah, this caps lock is active. Okay, wait. So what I need to do is I need to specify my projection zone in a different way, because it's too small, and I want to go overhead. We need to find a way to deal with this. We will. Because now I can show you how to use the beam table. We have this beam, it's that one at the moment, and we can move this beam that way. We go as high as possible, so we kind of go higher and put something underneath. Okay, here we go. So, we're hitting the truss. It's not ideal, but we just do it. So you see we have the beams, and we can just play with a keyboard or with any other device like MIDI or whatever. We can shoot these hot beams above the crowd. And this is the effect that can really wow the crowd, because the signal beams are so intense, we have the full power.